Hello, this is Emmanuel McCrimmon, and I'll be going over my demo for the programming project to solve the closest pair of points problem using the brute force and divide and conquer algorithms following the class pseudocodes. So here we have the brute force code, um, and then down here we have the divide and conquer following the pseudocode from class, and for compilation is the compilation is not required because it's run in Python. So we just go up here, we press run code and it'll run. So no compilation required. As for the point generation, we do that down here. So we use the random, we use a seed, and for each value of n, I generate random 2D points using the randgen points function, ensuring that the same input is used for both algorithms in each trial, and the points are randomly sampled in this range 0 to 32,767 and stored in a set to guarantee uniqueness. And then to calculate the runtime of the trials, we use this calculate runtime, and it calculates each trial, the time at the start of the trial, of each trial, and the start at the end. And then we use this run the experiments. It'll run each of the 10 trials for each n value, and at the end it'll calculate the average by summing all 10 of those times and dividing it by the amount of trials, which will be 10. And then oh yeah, and then we can over here we can see that we set the n values here, and both are ran on the same n values each time. So this one is the brute force for the range between 10 through 100 with an increment of 10. And you see right here, brute force will be ran on it, and then the divide and conquer will be run on it. And then over here we have 100 to 1,000, and brute force is run on it here, and divide and conquer right here. And we're using this because the original values, they were used for the report, but for this quick demo, we'll need to use these to demonstrate it really quickly. And then yeah, okay, so yeah, no compilation required, just press run code. And then as you can see here, the brute force goes instantly, divide and conquer. But then down here for this one, the brute force took a little while to do 100 to 1,000. But yeah, you can see it's hard to tell. You can't really tell. This one is just really to show it on a very simple test case for between 10 to 100, and also here. But when you go down to here, 100 to 1,000, you can already see the brute force, the algorithm, uh, growing quadratically, and taking longer and longer as the n increases, while the divide and conquer grows very slowly in time, which is consistent with its theta log n complexity. And yeah, that was it for a quick demo on simple test cases of my algorithms. Thank you.